Hello, this is Hoofert from ExcelDNA. Today we're looking at different data types that can be used on an Excel sheet and how these data types are then passed to user-defined functions that are created in VBA or created in .NET with an ExcelDNA add-in. I want to show how code that deals with different data types in VBA might be converted to the .NET side, and what is similar and what differs, and how to understand how the data types from Excel then map through to the programming language where the UDF is defined. Okay, I have a new repository called ExcelDNA Tutorials where I'm going to put the code and the write-ups for the different tutorials related to ExcelDNA. And I've added today's tutorial on UDF Argument Types in VBA and .NET to this repository. If I go to that directory, you'll see there is a solution and add-in project in addition to the write-up for the tutorial. And there is also a workbook associated with this. The easiest way to download all of the pieces from the tutorial is to go back to the top of the repository and click on Code, Download Zip. If you're familiar with Git and GitHub, you can clone the repository and synchronize it locally that way, but the easiest way is just to download a zip file, and that's what I'm going to do now. I'm going to move the zip file to a convenient location, so I'm just cutting it there, and I'm going to go to ExcelDNA. I'll make a new folder called Tutorials and put it there, and then I will extract the files over here into Tutorials. Let's see what it does. Okay, so it gives me Tutorials Master, and in there under Fundamentals, Argument Type Basics, that's the story I'm looking at today. Okay, what we need from here is we're going to look at the Excel workbook, Argument Type Basics.excelsm. That has a little example and some VBA code that we'll also be looking at. I'm just going to enable editing here and enable the VBA code and ignore the warning. So we're going to start there, and then later on I'm also going to open this solution in Visual Studio, which is an ExcelDNA add-in that shows how the types work in the .NET side. Okay, maybe I will hide some of these columns just to make my story a bit simpler. There we go. Okay, so I want to talk about the different types of data that can end up in a cell in Excel. So you'll see a case here where a cell is empty, and you'll see some cells where I've got numbers. They are written differently. This one looks like a whole number, an integer. This one is in scientific notation. These two cells are interesting. This is a date and a currency. It's formatted with the South African Rand currency, but it would sometimes be a dollar or pound, depending on your locale. This one is a string. This, I don't know if you can see it, but it's got a little dash there. So this is not actually an empty cell. It's a cell that's got a string in, but the string is an empty string. So that's a bit different from a completely empty cell like this one in B2. I've actually described the value types here on the left. I was hiding that. But we've got an empty cell, we've got numbers, and these two are date and currency formatted numbers, but the date that Excel displays is really just a formatting option for a number. So this number might be displayed in that format or in this date-like format. Excel doesn't really have a data type for dates for sheet values, and the same holds for currencies. So those are just formatting options, and we'll see that has some implications later. Excel does have a data type for Booleans, so these are the true or false logical values, and then there are various errors, and I've used a different formula in each of these to create the different errors, something that doesn't make sense in the different cases. The spell error is interesting. I have installed here an Office 365 version that's up to date and supports the new dynamic arrays feature. And so if I try to put an array like this, a literal array with a single column and two rows, then if there isn't room for that array to fit in, it'll give this hash spill error. But that's a strange error. We'll see it doesn't behave like the other errors in some respects. Over here I've got the curly braces around the formula, so this is a Control-Shift-Enter array, and if I press Control / it will select that whole region, and okay, it's a 2 by 2 array. As I can see it, I've just entered it as a literal array in the formula, but then with Control-Shift-Enter, this is a similar array, but without Control-Shift-Enter, it's a dynamic 2D array, which now has been able to spill over the 2 by 2 cells, so there's no error. This is a single row and a single column array respectively. And this is an array literal, but I'm using the operator. You can, if you have again a version of Excel that supports dynamic arrays, you'll see quite a lot of this operator, some depending on what kind of functions you use. And so this is a case where I'm kind of saying use only a single value out of this array and return that to the cell, and that prevents it from spilling or trying to spill, and so I end up with only a single value. If you put an array literal in old Excel versions that don't support dynamic arrays, you'd get the same effect where there is if you enter the formula without the @ in old Excel, and you don't do Control-Shift-Enter to make it an array, then it returns just a single value. So even though the formula returns an array, the cell value is just a single value, the first value out of that array. Then I've got the new linked data types. I've got one example here. I put in MSFT and then interpreted that as a stock data type. So if I go to data stocks, then that will interpret the data type as, in this case, a stock, Microsoft Corporation. And I will talk a little bit about the linked data, but this is not quite the topic for today. But these linked data cells then have a way of providing you with additional information about that stock in this case. The additional information that it returns is just a normal number. So that cell is a strange cell. It has this linked data type in, and we'll see it gives difficulties when trying to deal with it sometimes. But this cell, which is referring to the one at the top and is dereferencing the specific property, it returns a normal number, in this case the year incorporated as the data value. Okay, so that one is normal. Okay, so this is the full range of possible values that Excel cells can have. It can be empty, it can have a number, it can have a string, it can have a Boolean, an error, and that's the whole set of values. And the rest of these are kind of arrays, but they don't affect that single cell as a number. But okay, there's an array around it, and similar with the dynamic arrays. And so the linked data is actually the only other one that's a different data type. Okay, so Excel has a built-in function called type. And type, if you point it to the cell, will tell you what the type of data is in the cell. And I've made a little function in VBA to just tell us what the name is represented by that type. I just looked at the type documentation, the documentation for the built-in function type, and it told me what the different numbers mean, with the exception of this linked data type at the end, which it didn't have any documentation for that I could see yet. But the type returns this number 128 for linked data cells. Okay, for arrays, for example, when I refer it to a whole array, the type knows that array is a different type. And so the types that it shows are number, text, logical value, error, or array, or this exceptional linked data type, which is 128 is the number that it returns. Okay, so for an empty cell, note that Excel is saying this is a number and not saying some other special thing. But we'll see that that empty cell does get transferred to UDFs in a different way. Okay, so let's now look at VBA. So I'm going to press Alt F11 here to open the VBA editor. And I'm going to start looking at this module called Variant Info. And this module has some functions that I'm going to use as examples for exploring these types. The first function here is what we've already seen. It's a function called Excel type name, and it just shows us those types. The function I'm really interested in is this one called VBA Argument Info. And the idea is that we can take a parameter. In this case, it's going to be a parameter typed as variant, and describe what it is that we've received. And so in this case, there's a bit of an analysis that goes through different checking steps to decide, okay, what is actually the type of variant that we've received. Note that I've marked this parameter as optional, and that means that the function can also be called without any parameter, and in that case, the arg variant will be identified through the isMissing function, and we'll be able to see, okay, it's missing, or otherwise, if it's not missing, we check if it is an object type, and if the object type is actually range. And if it is a range which is passed in, so that's what we'll have if we call this function with reference to some particular range, then we're going to explore a little bit further what is in that range. Now I'm going to come back to this story. Arrays we're also going to deal with a bit separately. And otherwise, we're going to use the analysis functions var type and a helper I've made called var type name. Var type tells us what type of data is inside that variant variable. And so the var type name helper just decodes that into something I can show as a string. So if it's a Boolean, we're expecting var type to return 11, and we will then write VB Boolean, which is the constant associated with var type 11. Okay, I'm going back to the sheet to show you a little bit about how this VBA Argument Info function might work. Okay, so I've got some hidden columns here. Let me unhide them again. I will hide the DNA ones for now. I'm going to come back to those. Okay, so I've got two columns here. The one calls VBA Argument Info with a reference, and it is going to be a reference to all of these example values in column B. And then in the second info column, I'm actually using a literal value in the formula. And so that's a little bit different from just referencing it, and we'll see where things go different between those two options. But the idea is that the literal I've got in here is actually the same value as I've got in that cell, but it appears now in the formula. Okay. So in the first cell here, I'm doing VBA Argument Info of B2. Okay. And then when it goes through, the first thing I see is, okay, it's receiving a range, and the range address is B2. And when I then look inside the range, the variable type of range.value is VB empty, which is correct. It's an empty cell, and so I've identified it. And so a similar story holds for these, where I've got doubles. And so interesting ones are date and currency. When a number value in Excel is formatted as a date, then the range.value property will actually return a variant of type VB date. I want to go back to the VBA and show you how this whole description has come about. So let me go back to the VBA. Okay, so in Argument Info, if we're passed a range, then I read both value and .value to. And the reason is they are sometimes different, and the respect in which they are different is exactly what I'm showing here. Is sometimes value, range.value, will return a date or a currency value, but value to will show you the real underlying number that Excel is storing on the sheet. And so when these var types differ, I actually show this extra information from value to, and that's what you're seeing in the case where we've got a date or currency formatted input. So I'm showing both value and value to in the argument info description. Okay, for strings, things are straightforward, including empty strings, booleans. Errors show an error code, and this error code is actually a COM error code associated with that Excel error. So there are different codes associated with Excel errors depending on the context. And so this is one type of code. Sometimes hash value is error code 15. But this 2015 is what it shows in this case. Okay, for arrays, arrays are going to be a big part of the story of my tutorial today. For arrays, what am I showing? Let me go back to the VBA and explain it. I am showing something called the array size, and the array size is a helper that I've made. It takes an array, a variant that is of type VB array. It figures out, using a little helper function, whether it is a one-dimensional or two-dimensional array. In other words, what the rank is of the array. And if it is a one-dimensional array, it reads the lower bound and the upper bound. If it's two-dimensional, it shows the lower and upper bound for the two dimensions. And if it's not an array, it shows an error. So if I go back to the sheet, then I can see, okay, the array here is a two-dimensional array. Its lower bound is 1 and upper bound is 2 for both the first and second dimension. Okay, it's a 2 by 2 array that I've got here. So if I look at that range that it refers to, it's a 2 by 2 array. So what's notable here is that in our UDF, we are receiving an array where the lower bound of the array is actually 1. And that is completely independent of the option base. So the default inside VBA, when you make an array, would be to have the lower bound be 0, so have a 0-based array. But arrays that come in from the sheet are 1-based arrays. And so that's important if you're indexing the arrays, or you need to understand how big they actually are. Okay, so that works perfectly well as we refer to these different arrays. This array, for example, is a single row array. So I'm reading it with this hash array expander because I've got a dynamic array here. It's a single row, so the row indices just go from 1 to 1, and the column indices are 1 and 2. They go from 1 as the lower bound and 2 as the upper bound. Conversely, for a single column, I get a 2-dimensional array, okay, in a similar way. Then I want to show if I point it at this linked data value, then I actually get an error. It's a hash value error. It's the same as hash value when I try to read it. Whereas when I look at the special property of this linked data type, then I am getting the double that it represents as it is. Okay, so that is how the variant values that we get into a UDF are representing the values that we had on the sheet. I want to show that there are some differences if we are actually putting the literal value into the formula instead of pointing it at a range somewhere else. First is that we are able to call the function with no arguments at all. It's because I marked it as an optional parameter. And in that case, it will identify it as missing and show missing. The next thing is that there isn't really a way to put a date literal in the literal part. I wonder if I say date, even if I said a date here, I'm expecting, so Excel will know it's a date. It will still interpret it as a double if that date is entered in the formula at the top. So it doesn't become a VB date automatically. It does. It knows that when a cell is formatted as a date, that it should read it as a date, but it doesn't know what to do when the value inside a formula is a number that somehow represents a date. So remember, Excel doesn't really have a date time type built in. It's just numbers that are represented in those ways. Okay, the next interesting thing here is I made a little note here. The spill value. So this hash spill. There's no way to actually put that value in the same way that you can put hash NA into a formula. So you can't actually say equals VBA Argument Info and somehow here put in hash spill. That doesn't work. He doesn't know what to do with that. And actually the error.type number looks like it might know about spill, but if you put spill in there, it also doesn't know about it. Whereas hash value, well, it knows about that. Okay, so somehow the error types that it lists, and these are all these new extended types, spill, unknown, field, calc, they're all related either to the dynamic arrays or to the linked data types. So they're new error types, and they somehow not completely the same as the original built-in data types. I'm not sure what to think about that yet, but okay, there's something to say for there. Another thing that is different if you've got the literal values in a formula is how single dimensional arrays are handled. So we saw that a single dimension array, like a single row, is still passed through to a VBA function as a two-dimensional array, where the one dimension is just got a single value. But when we actually put a literal into the formula, and I'm guessing that would be true also if we make a function that returns some kind of array, then sometimes the VBA side will receive a one-dimensional array. So the dimensions of arrays are a little bit trickier when we're dealing with it in VBA. I actually want to check something. In my Excel here, because I've got dynamic arrays, I can make a function like sequence3, and that returns a little array with 3 entries in, which now the dynamic arrays will spill into the extra values. I just want to see if I do this VBA Argument Info and I put sequence3 inside there, whether it is a one-dimensional or two-dimensional array. So let me have a look. Okay, so it makes, in this case, a two-dimensional array, and it says there are 3 rows and 1 column, which is similar to how it's built it onto the sheet. Okay, so it's a little strange that we actually get one-dimensional arrays in VBA in some cases. That makes it a bit of an unusual distinction. Okay, let me go back to the VBA. Okay, so that's what I wanted to show you in understanding how the data types are passed into VBA, and this is what I want to contrast with the case with ExcelDNA when we make a function that can take various data types. One of the things that let me see if I've got an example here that I want to mention. Okay, so these functions at the bottom, for example, VBA Argument Boolean, that's just showing that if your argument to your UDF is not variant but is a particular type, like double or integer or string or Boolean, there are a bunch of different ones that are supported, this UDF, when it's called from the sheet, will now have to convert whatever the input value is into a Boolean. So it has to decide whether that input value is true or false. Or if it can't do this conversion, it will return hash value. Okay, so for integer, for example, if it's a double, it will round it to an integer. Okay, I want to see, for example, what happens if we do VBA Argument Boolean and take these different input values. So if it's an empty cell, then argument Boolean will say false. If it's a number, in general it will be true, I am guessing, unless it's 0. Okay, what will it do to a string like hello world? Okay, it can't convert hello world to a Boolean, so it says hash value. True and false it's happy with. I'm guessing the errors will just be errors, and so all of those error values can't be converted to a Boolean. In fact, in these cases, that function is never called. I mean, if you put a breakpoint in the VBA, it will never stop there. Okay, and then for arrays, okay, so these are values like, okay, when it's true, it's, okay, when it's 1, it's true. Yeah, all numbers that aren't 0 will return as true, I'm thinking. And then again, the empty cell is false. So what you're seeing here is that Excel is actually doing this conversion between whatever the input type is here and those Booleans. Similarly, if we went integer, let's see how Excel is converting this to an integer. Okay, so for an empty cell, it will interpret that as 0. For a number, it will round it. Is it truncating it or rounding it? Well, if we make this 1.9, we see it goes to 2. Okay, so it looks like it is rounding it. Some numbers are too big to represent as an integer, and then it will give this hash number error. Okay, that's interesting. That number on its own would not be a problem when converted to an integer, but because it's formatted as a date time, it looks like Excel decides it cannot convert that number that is a date time into a number. Let's see if we change that. It doesn't make a difference. 44,000 is too big for an integer. It needs to be a long. I think that's what's going on. So it's nothing to do with the date. It's just that it can't fit into an integer which has a maximum of 32,000 or so. Okay, Booleans are converted to minus 1 and 0 for true and false respectively. Okay. And so what we're seeing here is Excel is doing its best to convert the data into the data type of the function. Sometimes it can be problematic if you're expecting specific behavior and you're not, and Excel is just, well, you need to know what Excel does. Okay. The next topic here is when we are interested in reading an array, there are different ways to do it. So I'm going to go to this range argument sheet, and again I'm going to start here on the left. So I just have a little list of numbers, 1, 2, 3, 4, 5 here, and the idea is to make a function that will look at the input numbers and will add up all the even numbers. So in this case, I'm expecting 2 and 4 to get added up into the number 6. Okay. So this is a function that takes an array or a range as its input to be able to calculate this sum. Let's look at this implementation. This is the VBA sum even numbers R function. I'm also going to have a V version of this. So the R version declares the input as a range. And then what it does is it says for each cell in the range, if the cell.value mod 2 is 0, so that's a way of saying if the cell.value is even, then the sum is incremented by that even value, and in the end we are going to return that sum. Okay, so that's a very simple implementation of this, but note that it then requires us to pass in a range object. So it requires us, in calling it from the formula, to put in a sheet reference there. So if we, for example, put in a literal array of numbers, this function won't work because it says hash value, the argument type is not understood. Similarly, if instead of the literal array, we try to use something like that sequence function, which returns a whole bunch of numbers, up to 5 in this case, that does not work because, again, it is not able to deal with the array that sequence returns. It requires actually a range reference. Okay. The next version of this function that I've made is a function that now takes a variant type. Things become more complicated, but the end result is a bit more flexible. So let's see how I've tried to deal with this. So now we say, okay, anything that Excel can give us, we'll be able to interpret or try to interpret as a list of numbers that we're going to sum up. And first off, again, if the input is an object that is a range object, then we're going to go through the different areas. This area story is about being able to handle union regions in a range, a union of references. And then for each of these areas in the range, we're going to add up a call to ourselves, a recursive call to ourselves, but now with the dot value of the particular area. So the array that is the value, or single value, or whatever it is. Okay, if it is not a range object, then I check if it is an array. And if it is an array, I have to distinguish again, is it a one-dimensional, two-dimensional array? If it's a one-dimensional array, we go through L bound to U bound, and we check and add up all the numbers. If it's a 2D array, we have to do it L bound to U bound for both dimensions to add it up. And then if it is not an object and it is not an array, we think it will be a single value, which we just check on its own. Is it even? And if so, that's the thing we return. So this function is more complicated than the first one, but it is more explicit about what it is able to handle, and it is more flexible in the inputs because we are not forced to give it a reference. We can give it actually any kind of value from the sheet. So let's see how that works with VBA sum even numbers V. Okay, sum even numbers V. Okay, so that's when it's got the reference. That works okay. Here's when we give the literal array. That works okay. And here's where we give a sequence, and in this case, if I go up to 5, it will give me the same value, but I can go up to 5,000, add up all the even numbers, and that's the result. Okay, so this is a bit more flexible because I can now build up formulas that actually also use other functions, and I'm not constrained by having to call it with a direct sheet reference. Okay, so that's, I think, a little bit better. You'll remember I had that whole story with the areas. This is an example of that where I am calling the function, but I'm actually calling it with these a union of separate areas, and in that case everything works okay if I take a range object because it's I'm going through the cells, but I had to do a little bit more work for that to work out. Where's my, oh, this is the one with the V, yes. Okay, I'm seeing some other functions here. These are the ExcelDNA ones that I wanted to show. Okay, and these are more DNA examples. So we're going to come back to the DNA examples with the 2D and 1D arrays. Okay, back to VBA. Is there anything else I wanted to show here? I don't think so. These are the functions at the bottom. Okay, so in a way this is an example of dealing with a variant, which is the most flexible parameter type for a VBA function. Okay, and we'll see what the kind of the equivalent is in the ExcelDNA side. Okay. So what I'm going to do now, I'm going to close Excel because I'm going to actually open up now. Am I going to save it? No. I'm going to open up the project that I downloaded from that GitHub file that I extend, this zip file that I downloaded, the argument type basics solution. So let me go to my directory, argument type basics. I'm just opening the solution, which it will open in Visual Studio. And let's have a look at this. So in this case, I think this is okay. Hope so. In this case, I have made a small add-in with Visual Basic, but Visual Basic.NET. So I made a new project, a class library .NET framework project. I installed the ExcelDNA.add-in package, and then I created some code, and this is the code that I've added. Okay, so we've got a single module here called functions. It's a public module, and so these functions, they will be registered with Excel and available. And so what I'm trying to show with these functions again is how the different data types come into the ExcelDNA add-in, because things are a little bit different, and that's what I want to show. This first function is one that describes the type of argument that came in. And the first thing you might notice that's different from VBA is that instead of variant, the data type that we use in .NET for the most general data type is object. And in fact, this function would be exactly equivalent to leaving out the as object part and just putting a parameter there, because again, the implied data type then is as object. So I'm kind of coding in option explicit style where I try to define the data types for clarity, but it makes no difference whether it is there or not really. Okay, in ExcelDNA, when we get an object, this is an exhaustive list of the possibilities. So it's either going to be something that is of this type Excel missing. So Excel missing here is some type that is actually it's actually the type called ExcelDNA.integration.Excel missing. And Excel missing is kind of a type holder type for the case where that argument is missing and nothing is being passed in. Okay, so let me just show you the list. It's Excel missing, Excel empty, which is a similar one. And then it can be a double, a string, a Boolean, an Excel error, or it can be a two-dimensional array. And that's the whole list of possible types that we need to prepare for on the ExcelDNA side in our function if our argument is typed as object. Anything else is completely unexpected, and you should report a bug with me if you see anything else. So we're expecting only these types. Later on we'll add one more here that is going to be called Excel reference, but only if we ask for it. So what happens if we get an array of objects? It will be a 2D array of objects, and what we're going to print out here is just the size, and note that U-bound and L-bound are I think they're available here, but I'm actually using the standard .NET approach of saying array.getLength 0 and array.getLength 1 to get the length according to the dimension with index 0 and the dimension with index 1. Note that all of the arrays that we get will be 0-based, so we never get a 1-based array in .NET, although some of the collections, and when we get to the COM world, often those object collections are 1-based when they come from Excel. But the arrays in .NET that we get for data will always be 0-based. So that should be clear. And then what could be inside this array? Inside this array it will be a collection of those types. Well, I guess empty too if it's a cell that is empty. So it can be empty, a double, a string, a Boolean, or an error, depending on what was in that cell. Okay, so I want to explore this DNA Argument Info function now in the context of that same spreadsheet. So let me run the add-in. It will load Excel, it will load the add-in, and I can then open that same spreadsheet again. I am surprised that it is not letting me run, because maybe it hasn't been built yet. I don't know what happened there. I think that when downloading a solution, it sometimes needs to be completely rebuilt for it to know how to debug it. So I'm not going to edit that little glitch away. I will tell you, if you download a project, you have to make sure that you rebuild it so that it knows that the add-in will be debugged in Excel. It's a little piece of magic that is added by the ExcelDNA.add-in package. And once it's rebuilt, it now knows, okay, the debug environment that it needs to run in is Excel. Okay, it seems to, I think it has worked now. Let me try to open the same sheet we had before. And I just want to see, are these DNA functions now available? So for example, DNA Argument Info. Okay, so I know the add-in is loaded because the function is available here. And if I can, yeah, so I can see that function is calculating and it is there. I'm just going to close this disclaimer about the financial information again. Okay, so these columns, I had them hidden before, but now I'm showing them. Again, the first column here is showing the references to these example values on the left. And so when I point it to, okay, an empty cell, it says, okay, that's an empty cell, a double. Notice that it is picking the dates and the currency as a double and not picking up the separate date or currency values. We can declare a function in ExcelDNA to take a date time parameter, and then any double that is sent to it will always be interpreted as a date. But it will not be able to tell that something is a date or a number based on the formatting. That's something we can't do in ExcelDNA. So we have to know what to expect. If we want to interpret that as a date, it is possible. It's just we have to know in advance. We won't be able to distinguish one type of number from another just based on the sheet formatting. Okay, things work okay, and then when we get to errors, we get a different way of representing the errors on the ExcelDNA side. We have an enumeration for these different errors, but they correspond to the standard errors in Excel, again until we get to this spill error, in which case things are a little bit weird. Again, we always get hash value for these additional errors. For arrays, things are a bit simpler than in the VBA side because it's always a two-dimensional array with base 0. If we try to actually read this linked data type value, we again get hash value, the same as in VBA, but the dereferenced properties are not a problem. Okay, notice that when I make a literal argument here for the different values, it is going to be exactly the same as it is when I do a reference. So if I don't pass in any argument for the value, then it will pick up that is missing. So that's different to pointing it at a cell which is empty. So I distinguish those two cases. But for the rest of the values, things are exactly the same. What's the difference here? Okay, so in this first case, I'm pointing it to a cell, but that cell, even though it had an array formula, it was just putting one value into the cell. In this case, I'm actually putting in the literal array in the formula, and so I wanted to experiment with the at I think makes no difference here. Oh, yes, that's right. So the at doesn't make a difference here because that just tells it what to return to the cell. So for the formula, I will always see the input there as an array. Okay. So whether it's a literal or whether it is a reference, it looks the same to ExcelDNA. We can read arrays and get all the array information without having to make a range reference, and that's going to be a part of the story here. Okay. So the extra part of the story is, okay, what if we really want to get the information of the reference that's passed in? So what has been different here is we never got a reference or a range passed into our function, even if we called it with a reference, because ExcelDNA or Excel actually in this case would dereference that into the resulting value and pass that to us. And so there is a way in ExcelDNA to indicate that an argument that is of object type should actually accept a sheet reference if that is what is sent in. And the way to do it is to use what is called an attribute in .NET. It's this angle brackets that mark extra information onto a parameter, and in other settings it could also be an attribute that is attached to a method or a class, and it is a way of adding extra information. Extra information here is it's an Excel argument type attribute, and it says allow reference equals true. And so what that means is it tells Excel that if we are passing in a reference, we want to get that reference in our function. And so we add this extra possibility that the type of the arg is Excel reference. And in that case, okay, we will at least write out it is a reference, and then we will go and we will do get value on the reference, which we can then pass to our normal documentation function to get the details of the value. But by writing the reference information in the front here, we'll be able to see that a reference was actually passed to our function. If it is not a reference that's passed, we just write the normal information. So we kind of jump into the normal case where we have one of these 5 or 6 values, types. Okay, so let's see what DNA Argument Info AllowRef does on our sheet. So I'm going to go here and I'm going to change this from DNA Argument Info to the same one with the AllowRef. Let's see what happens. Okay, I will tell you what it is showing us here. Well, if it is unhappy with something. Oh, it didn't like get value. Okay, we'll have to see why that happened. Okay. In this case, I'm writing out some information, and you'll see this long number that's actually an internal Excel sheet ID that identifies this argument types sheet. And then the first part here is the rows and columns of the reference. So I want to see, for example, is this one we can do. Is that okay? So this one you can actually see the array size. So I'm seeing that it is row 20 and it's got one row, and column 21. Now how I'm interpreting this is a bit confusing to me. I think it's a row. The first row and column is row 20, column 1, and the indices here are 0 based, and that's what's going on in this reference. Okay, so this is a little bit confusing, but what I'm writing here is information about that reference. That's enough information for us to recover the exact reference that it's pointing to, which is in this case this area, which is row 20 to 21, 0-based indices, and column 1 to 2, again 0-based indices. That's what that means on the sheet with that special sheet ID. And what is the value that's inside there? It is a 2x2 array. Okay, and then we could again examine inside that 2x2 array. I'm not sure why that .get value gave an error. I don't know. Okay. So what am I trying to show here? It is possible with ExcelDNA to make a function that will take a reference. Okay, and this reference could then be turned into a com range object from where you can do other stuff like read the background color, I guess, or something like that if you need to. So you are able to do that conversion. I'm not going to discuss that in this tutorial, but it is possible to use the information in the Excel reference to construct a com range object. It is also possible to use that Excel reference to call into Excel to get information about the reference, or to store it somehow in a data structure so that it can be used later. That's something that ExcelDNA does in some cases internally. So it's useful to know that this feature is available to allow reference, but it is actually it is unusual to need it, because the default behavior actually gets you all the values you need as input to the function. So often people ask, okay, I've got a VBA function and it takes a range. I'll go back to the VBA here. It's a VBA function like that, and it takes a range. How do I use the range parameter in ExcelDNA on the ExcelDNA side in C# or VB.NET? And the answer really is, well, I'm guessing the reason why you want a range is because you're going to look at the values in the range. And if you're going to look in the values in the range, then probably you don't need the range itself. You just need to understand that you might be getting an object array with all the information as one of the options for what you get into your function if it's declared with object. And that's normally the answer to how do I deal with code that in VBA would be a range object. Okay, so that's kind of a basic, but in some places quite detailed introduction to the Excel sheet data types, how the data types are converted to variant parameters in VBA, and how object parameters in ExcelDNA add-ins and functions have a similar role. There is more to say about these data types, and in particular about that conversion between Excel references and com range objects. But for now, I think this is the basics and gives you some idea of the details one needs to take into account if you are moving code from VBA to VB.NET with ExcelDNA. If you have any questions or suggestions about this, the best place to ask is on the Google group, or in the comments on the YouTube video. I think will be fine as well. Okay, that's my story for now. Goodbye.